Hello everyone and welcome to the new episode of our series of solving LeetCode Daily challenges. And today we are going to solve a problem called maximize the confusion of an exam, which is classified as medium. And here I think it's a valid classification for this task. And let's go to the problem statement. So we have the history, like the legend of the problem, is that there is an exam with questions, each of which has an answer either true or false. And our professor wants to confuse the students by maximizing the number of consecutive questions with the same answer. Okay, and we are given a string answer key, and basically each character in the string represents an answer to a question which can either be true or false. So our string consists of letters T and F. And we can perform no more than k changes to the string, and each change is basically we change the answer to one specific question from true to false, or the other way around, from false to true. And we need to return the maximum number of consecutive T's or F's in the answer key if we can perform at most k operations. And let's take a look at the constraints. So the answer key length is up to 50,000. Each letter in the answer key is either T or F, representing true or false. And the number of changes is between 1 and n, so also between 1 and 50,000. Okay, so that's our problem. It's kind of similar to a couple of previous problems that we were solving. Let's go and talk about the idea of the solution. So we need to make a couple of observations before we can start implementing the solution. So the first observation is that in an optimal solution, there is no need to change the answer keys in our string answer keys to both true and false simultaneously. So basically, in an optimal solution, we either need to change false answers to true or change true answers to false. And okay, the next observation is that we can assume that, suppose that in the optimal answer we need to change false answers to true. Then in this case we can solve for this specific scenario. And now suppose that in the optimal answer we want to change true answers to false. We can solve for this specific scenario, and our final answer is basically the maximum number among these two solutions. So basically we can solve independently for these two cases and choose the maximum, and that will be the answer to our problem. Okay, suppose now our problem is basically reduced to a slightly simpler problem that we always convert, like, let's say, false answers to true answers, and the opposite case is handled in exactly the same way. And we want to find out what is the longest segment of, let's say, T's that we can achieve if we do no more than k changes. And to solve this problem, once again, we can use true pointers. And this technique was explained in my yesterday's video. So if you haven't seen it, go check it out. It's pretty cool. But of course, I will show how to apply this technique to this specific problem. So suppose that our target char is equal to t, meaning that we will be changing f's to t's. And suppose that we can do no more than 2 changes. And suppose that our answer key is like this string. What are we going to do? We are going to iterate through all of the possible left bounds of our segment. So we want to iterate through all of the possible beginnings of the segment that is going to contain only t's. And for each possible beginning, we want to find what is the maximum length of the segment of t's achievable if we can do no more than k changes. Okay, so let's start with left bound equal to 0. And for this scenario, the answer is quite easy. We can just iterate through our string. And here is what we are going to do. We are going to look at the our new character, and okay, we are taking a look and we see that it's equal to f. Okay, we want it to be equal to t, so we still have two changes available. So we will change it to t, and now we have only one change available. The next character is equal to t, no need to do anything. The next character is equal to f, we need to change it to t, and we still have one change available, so we are changing it to t. But now we have no more changes left. Now we are going to look at the next character. It's equal to t, no need to change anything. The next character is equal to f, however, we no longer have any changes left, so we have to stop before this letter f. And the answer for left bound, which is equal to 0, is 4. We have to stop in here because, yeah, we've used all of our changes. So the appropriate right bound of our segment is equal to 4. And the answer is basically right bound minus left bound and equal to 4. What if we move our left bound by 1 to the right? So left bound is equal to 1. Now we do not have this character in our segment anymore, and this character was equal to false. This means that now we have one more change operation available to us. So let's apply this change operation, and then we have 3 answers equal to t in a row, and we can also include them in our segment without applying any operations. So yeah, now our right bound is equal to 8, because yeah, this is the character number 8, and our left bound is equal to 1. So the length of our answer is equal to 7. And yeah, it's easy to see that in this segment we have only 2 letters f, and we can easily change them to t using exactly k operations. Okay, so our current best answer is equal to 7. Let's take a look at left bound, which is equal to 2. Our previous character was equal to true, so we do not have any extra change operations, and because of that, the right bound of our segment doesn't change, and because of that, the optimal length for left bound of 2 is equal to 6. 8 minus 2 is 6. And now suppose that left bound is equal to 3. The previous character was equal to false, which means that we can do one more change to the right of this right bound. And this is exactly what we are going to do. We are going to change this letter f to the letter t and get the answer of the length 6. But the optimal answer, we achieved it when we have a left bound equal to 1 and right bound equal to 8. So basically our algorithm can be summarized to this. When left bound is 0, we simply simulate the process. We go from the beginning until we still have some operations left, till we either reach the end of the string or find an f character that basically corresponds to the situation when we no longer have an operations for change. Okay, and for each of the next left bounds, here is what we are going to do. We are going to take a look at the previous character. If it's equal to f, this means that we have one more change available, and we will change the next letter f to t, and then we will also probably enhance our results by all of the following letters t. Okay, and if the previous letter was not a letter f, but the letter t, It basically means that our right bound doesn't change because we do not acquire extra change operations. And yeah, that's basically all of our solution. Let's take a look at the code. The code is pretty straightforward. So as I've said, we solve independently for character T and for character F, which is our target char, the char which we are going to change towards. So at the beginning, we are calculating the answer starting from beginning. So for this case, when left bound is equal to 0. And to do it, we just iterate through our string and we check the current character in the string. If it's a target char, then we simply increase right bound. If it's not a target char and we still have some operations left, we increase our right bound, but we also decrease the number of operations available. And otherwise, we've encountered a character that is not a target char, and we do not have any operations left, so we need to break and end our iteration. And we return this right bound. So we have calculated this answer for the left bound, which is equal to 0. And then we are going to iterate through all of the possible left bounds and try to improve the answer for them. So basically, if our previous character is not our target character, just like we had in here, then we can expand our answer, and that's exactly what we are going to do. So this is how we are going to do it. If we reach the end of the string, then okay, there is nothing left to improve. Otherwise, we are going to convert the next character, which is by definition not our target character, and then so this is this letter F, and then we are going to try to collect these letters T and also include them in our result, which is exactly what this for loop is doing. And yeah, so we've recalculated our right bound, and we can update the result by we are telling that it's a maximum between our current result and the result for this specific left bound. And in the end, we return result. So what's the complexity of this solution? The complexity of this solution is big O of n. And yeah, once again, it might sound weird because here we are iterating through all of the possible left bound, and inside of this loop, we are doing another while loop. So you might say, okay, we have two loops. How in the world the complexity can be linear? And this is exactly what we had yesterday. It's not important how many loops do we have. It's important how many operations all of them combined perform. And basically, our left bound will change exactly n times, and our right bound will, in total, inside all of these iterations, change no more than n times. And basically, this idea is called amortized analysis, and it's used in many, many algorithms. So I suggest you to read this article or to read some maybe better educational articles about amortized analysis, because yeah, it's a concept that we encounter all of the time. For example, in the, some of you might know the Knut-Morris-Pratt algorithm, and yeah, it's a very common technique. Okay, so let's talk about the lessons from this problem. So there are several lessons that we can get. So one of them is that two-pointer technique really might be useful because yeah, we encounter it for the second day in a row in this daily LeetCode challenges. And the second lesson is that amortized analysis is worth learning if you haven't heard of it yet. Okay guys, so thank you very, very much for your attention. If you like this video, press like, subscribe, and I will see you later. Talk to you later, guys. Bye-bye.